Hello, and welcome. Today we're showing how easy it is to run and deploy C-Nex from scratch. So the first thing we're going to do is to clone the repository, and for that I'm using GitHub Desktop. While it is cloning, let me show you what we need Visual Studio to have so we can run our app. 1. We need the ASP.NET because we're working with Blazor. 2. We need the data storage and processing that would allow us to view the database and its tables and edit them from within the IDE. 3. The dotnet desktop. I don't think we need since I probably had it installed from other projects. The cloning is done, so let's jump into Visual Studio. We have our solution to the right, and the SQL Server Explorer to the left, and as you can see we have no database set up yet. There's only the databases of the system and Visual Studio itself. Back to our solution to the right. As you can see, it's quite tidy. First, let's check our dependencies list and how the project is structured. As you can see, we kept the project dependencies strict and up to modern standards. And to make sure of that, we've set up an arch test that we'll go through later on. As for now, let's set the starting project to the cnex.web before we forget to do so. Our next station is the app setting JSON file. The file itself is parent to two other subfiles, appsettingjson.development and appsettingjson.production. They're almost exactly identical except for a couple sections. Ignoring the log sections, this is a database provider and encryption section. As you can see in the development file, we have both the MS-SQL and PostgreSQL connection strings. While down below, we have the local server custom ports configuration. There is also the AI providers configuration section. It's almost 100% the same over the production file. Database provider configuration, encryptions. Only here we have a single connection string to avoid any issues with the hosting server. There's also the AI configuration section. Here you can simply paste your API key for any provider and there you go. In the program.cs file, this section here handles localization, while this one below is responsible over executing the app migration, as well as updating the database automatically. Let's build a solution first. Doing so will give us the ability to explore even more stuff. So let's give the process a second. The build is done. There are no issues. Time to do something fun. And by fun I mean let's have some unit tests. We managed to have around 39 unit tests along the main 5 architecture tests. Let's give them some time to do what they are meant for. Show some green. And with all the tests green, some statistics will be great. So let's explore the code metrics of the app, starting with a unit test project for some legitimacy. We have around 1.5k line of code there, and around 75k around the whole app. For the metrics, the app shows some healthy figures for both maintainability and complexity, affirming our efforts to keep everything as simple as possible. The issue in numbers, as always, is because of the app migrations, which drags the maintainability score as low as it can, and that should be a natural part of ASP.NET, where we're having a top score of 29. We're done with tests. We're done with metrics. Time to launch the app. In the console window, you see the app checking for migrations, configurations, and updating the database automatically. There's also a script to seed initial data, like creating an admin account and basic app roles for as to use in the demo. This is the app landing page. We kept the UI as simple as possible and focused basically on functionality. As you can see on the top bar, we made sure to provide a theme toggle as well as a language selector to make it easier to explore the app. The language selector supports 8 basic languages, which the resources were translated by AI. We apologize for the shortcoming already. With the localization feature, there comes also the option of changing the app orientation following the language-preferred writing direction, as we can see with Latin languages like English and French versus Arabic. I'll leave you for a bit while you explore the landing sections and pages, and see you when we log in the app. In the Brave browser, we have some saved data which we're using to log in, yet we prefer a fresh experience, so we will be swapping to Chrome guest mode. There's also the reason that while in debug mode and with local hosting, Brave will break the app connection since it doesn't allow transfer of large files, so uploading will be restricted for us there and we don't want that. Once we're logged in and with the app, we're greeted by the App AI chat window, which require an API key and a default provider selection to work properly, and some other filler cards as placeholders. This time we're jumping straight into the app settings section, where we'll start with exploring the theme toggle tool. By default, the app comes with 3 pre-configured MUD themes that can be adjusted or removed if necessary. Next to it is located the User Management Hub, where CRUD operation on application users can be held, as well as some other features like the role management feature, as well as the demo tenancy swap feature, bans, and accounts deactivations. Bans can be set to certain period, which after expiration the accounts are back in activity automatically without the need for admins to intervene manually. On further exploration, there is the AI Services Management Hub, where 3 main providers are pre-installed. For these 3, all you need to do is either register the API key on the app settings file as shown earlier. That part should be a backup since it's not tenant adherent, or preferably use a UI to store your tenant-related API key in the DB through this hub. Next, there's a Payment Gateways Hub, where by default it supports 2 main providers, Lemon Squeezy and PayPal. In a similar way to AI providers, this hub uses the same logic, except we drop the app setting configuration to avoid any kind of tenancy conflict. For testing, just use a provider sandbox mode and fill the required fields to test the services. We're skipping the local storage engine for now and diving straight into the audit system, where as you can see it records all CRUD operations that occur across the app and shows the details of the operation, focusing on answering 3 main questions: who, what, and when. The UI in this section is quite rich since it's a bit of a complicated part of the app. We also made sure to make it easy for admins to filter through these information with ease and precision by providing a variety of usable filters. There's the most obvious filter by date, which we brush by since our DB is too fresh to have any. Then there's a filter by action such as created, updated, or deleted. And finally, filtering by module type, and by module we mean entity. Delving back into the local storage service, which we consider like a premium feature to manage disk space on servers. Through this service, you can control the maximum quota size you want to dedicate for your media storage on the server, as well as pre-configure any upload to be compressed and converted to WBP format, maintaining 80% of the image quality, and maxing the aspect ratio to your pre-configured values. Focus on our uploaded picture size before and after the upload. Even though the size of the original picture was small, 215 kilobytes, the size after the upload and compression is way well optimized with next to no compromise in quality. 55.17 kilobytes, around 26% of the original size. On top of all of that, the service is smart enough to create dedicated folders for each type of uploads following the service from which the media file was updated from. The service excludes by default the compression of GIF and SVG file for their technical nature. Now that the demonstration of the app feature is over, let's talk about online deployment. For our service of choice, not sponsored or anything, just personal preference due to the ease of use, is none other than monstersp.net. I've already went it and set up a domain and a database to use for this session, so follow closely. All we have to do to deploy our app is to enable and download the web deploy profile from our created website. Upon download, we head to the database section and simply copy the provided connection string and paste it into our production app setting JSON file, and replace those styles with credentials we obtained from the Monster ASP database platform. The final step in the deploy process is to right-click on the .web project and press Publish. Then you're prompted to select a Publish profile. You select the one we just downloaded from Monster ASP and press Finish. Everything is set up now. As a final step, and make sure the changes we made to the app settings file were applied properly, we rebuild the solution for one final time and press Publish. I'll spare you the boring upload part and skip to the end where the finish process will automatically redirect us towards our live website. The first time the website loads will take some time because we skipped all the manual configuration of the database and left it for the app to do on first start. Now our app runs smoothly, with perfectly seeded initial data as well as a perfectly fresh database. With this, our introduction of the C-Nex Boilerplate is done, and do not hesitate to visit the website and explore the app. The credential to log in as an admin will be provided here in the video, as well as my information are included in the website as well. We're preparing to put the app on sale as soon as possible. For any information, do not hesitate to contact us. I hope you guys enjoyed the video and the project was worth your time. We welcome all sorts of positive feedback, so don't hesitate to leave a comment and share your opinion. And let's see you in the next video.